Welcome back to section 5.3. We're learning about determinants, and you'll notice that I have the same example twice here, and that's not a mistake because I'm going to show you two different ways to do this. So first of all, let's remember our diagram that guides us. It's plus minus plus, minus plus minus, plus minus plus. And that's kind of our guide as we do this. Whoa, lose my focus there. So let's take a trip just like before across the top row. And let's do it. So we see that it's going to be positive. So positive 3 times the determinant of, ignore the first column, and ignore the top row. So it's going to be 5, 6, negative 6, negative 4. Our next journey is to here. So we see that it's going to be minus negative 5. So I got one negative from the negative 5 and one negative from the negative here. So those become pluses. Okay? Anyway, so now we ignore this middle column and ignore the top row. And we're going to get 0, 0, 6, negative 4. So 0, 6, 0, negative 4. Okay? Then finally we have a plus. So plus, it's going to be 1 times 0, 5, 0, negative 6. So there's what the determinant of this 3 by 3 is made up of. So it's made up of 3 of these 2 by 2 determinants. So let's do this. So 3 times 5 times negative 4 is negative 20. Minus negative 6 times 6 is negative 36. So just be real careful not to drop a negative sign. 5 times negative 4 is negative 20. Minus this times this, which is negative 36. So those will become pluses. Now we have plus 5 times 0 times this is 0, minus 0 times this is 0. So we have 0 minus 0 in there. Plus 1 times 0 times this is 0, minus 0 times this is 0. Interesting. So this is 0, this is 0. So we only need to deal with this. So 3 times 36 minus 20 is 16. So the determinant of this matrix is 48. Cool. However, we did a lot of unnecessary work because as you noticed, this determinant right here and this determinant, they both ended up being zeros because of these zeros right here. So it's actually possible to do this problem with a little less work. Now, do you see how I started this problem by going across the top row? You don't have to do that. You can actually take a trip along any row or down any column, and when you do that, you'll actually get the same determinants as long as you use this diagram and make sure you make your 2 by 2s correctly. So let's do this. Instead of going across the top row, let's go down the first column. Okay, so let's do that. So again, we're starting at the positive, so it'll be plus 3 times the determinant of, ignore the top row and ignore the first column. So 5, 6, negative 6, negative 4. Okay, that's kind of the same as last time. Now I'm going down, so now I have a minus here because that's where I'm in the grid. And it's going to be 0 times the determinant of, ignore the second row and the first column. So that's going to be negative 5, 1, negative 6, negative 4. Negative 5, 1, negative 6, negative 4. And you realize that I actually didn't even have to write this because it's everything times 0. But just for practice, I wanted to show you what it was. So again, ignore the second row and the first column, negative 5, 1, negative 6, negative 4. Finally, we have a plus here, so the diagram is plus 0 times negative 5, ignore the bottom row and the first column, so negative 5, 1, 5, 6. All right. And you can see that this is 0 and this is 0. So really, we only need to do the first one. So 3 times 5 times negative 4 is negative 20. Minus negative 6 times 6 is negative 36. these become pluses. So it's 3 times 16, which equals 48. And you see that we get the same answer as we did in the previous example. And hopefully you feel that that's kind of cool. You could even go down this row if you wanted to, and notice that when you and just following the same pattern where you circle the number you're working on, eliminate that row, eliminate that column, and that gives you the other 4 numbers of your 2 by 2. So, and every time you do it, it should equal 48 in this example. Let's do this last one and then we'll call this video a good one. What column or row do you think I should travel across to do this problem? The correct answer is to travel across the second row, because that's the row that has 2 zeros in it. So we can save ourselves some work. So let's do that. So our first, again, we're going to use this diagram. So again, you got to use this diagram. So notice we're starting here. So this should be -0. Now, I'm not even going to figure out what matrix it is, because it's just 0 times whatever it's going to be. So I'm just going to put a little smiley face right here. Now, I'm going across the middle row, so this right here is a plus 1 times, ignore the second column and ignore the second row, so basically it's going to be the 4 corners, is this determinant, so 5, 3, 7, -6. Then my diagram says I have -0. And I'm just going to put a smiley face in here because we don't care what it is, because it's just 0. So this is 0, this is 0, and so this is going to be 1 times 5 times -6 is -30, minus 7 times 3 is 21. So 1 times all of that is just going to be -51. So there you go. Now, just for the record, I like putting in the smiley face just because I know I can, but let's just see what those matrices would have been. This one would have been 5, 3, 2, -6, if we did that, and this one would have been 5, 5, 7, 2. But again, that doesn't really matter because you times it by 0. So really quickly, let's talk about how you do a 4 by 4. Say we had this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. How would we determine the 4 by 4 determinant? Well, you essentially kind of do the same thing. You still use a diagram like this, except now it would be minus, plus, minus, plus, minus, plus, minus. So you'd have a 4 by 4. And you still take a trip across one row or one column. And so this would be 1 times, and then you have to do the 3 by 3 determinant. So 6, 7, 8, 10, 11, 12, 14, 15, 16. And then, so that would be positive, and then the next one would be -2 times, and then you have another 3 by 3 determinant, and then another 3 by 3, and then another 3 by 3. And you see how long it takes to take a single 3 by 3. So you can see that this kind of exponentially takes more time every time you add another row and column to find a determinant. And remember, we really only care about determinants for square matrices. There's not any 4 by 4s on your homework. I just wanted you to see that it is possible to do them, but man, it does take, let's see, the next one would be 5, 7, 8, because we're ignoring this row, 9, 11, 12, 13, 15, 16, then it would be plus 3 times something, and then minus 4 times something. And then within each one of these, you need to do a 3 by 3 like these. So it takes a while. Anyway, so what do we use this special number for? Well, we're going to use it for, it has many uses, but we'll look at one on the next video, which is about Cramer's rule. And as always, if this was helpful, please like and subscribe, and see you in the next part.